This is 2022 AMC 10B Problem 6. Consider the following 100 sets of 10 elements each. How many of these sets contain exactly 2 multiples of 7? So for one of these sets from 1 to 10, 11 to 20, etc. to contain 2 multiples of 7, there has to be a multiple of 7 at the front of the set, at the front, from 1, 2, 3, 4, etc. And then also at one multiple of 7 at the back of the set, like 9, 10, 8, stuff like that. So what exactly are the requirements so that we have 2 multiples of 7? Well, the first, the 7 at the front should be, it can firstly be, so if we call this number 7k, it can have a remainder of 1 when it's divided by 10. Now what this means is that this front number is one of these, 1, 11, 21, etc., all the way to 991. And for a set of 10 elements to meet this requirement, it has to have its first element as a multiple of 7. So which elements satisfy this condition? Well, firstly, let's look at the unit digit of 7 multiplied by something and see what unit digit gives us a product of unit digit 1. Well, we know that 7 times 3 is 21. So 7 times 3, 7 times 13, 7 times 23, etc. all the way to 7 times up to this number. 7 times say 300, or wait, not 300, that's too big. But anyways, 7 times anything with a unit digit of 3 will result in a unit digit of 1 as a product. So how much k's are there? There's 3, 13, etc. all the way to, well, we know that 103 is 721 times 103 times 7 is 721. So 113 is 791. 100 so let's look at 133 times 7. That's 3 times 7, which is 21, and 3 times 7, which is 21 again, and then 1 times 7, so that's 931. So 133 is the biggest number that ends with a 3 that we can multiply 7 by that does not exceed 1000. So how much numbers are there? There are 133 minus 3 divided by 10 plus 1. So that's a total of 14 numbers. And then we can also have 7k is congruent to 2 modular 10. So in this case, for 7, we need k to end with 6, 16, etc. all the way to 136. There's 14 numbers here again. And then we have 7k is congruent to 3 modular 10. This is the last one, because if the first number is one of these numbers, then the second multiple of 7 will be one of these numbers. For example, in one set we can have 63 and 70. So here k will be 9, 19, etc. all the way to 139, which there are 14 numbers again. So the answer would be 14 times 3, which is 42.